Today I am going to solve the homogeneous differential equation of a higher order. I have a equation d square y over dx square minus 8 dy over dx plus 16y equal to 0. To find out the complementary function of a given equation, I have put the right hand side equal to 0. I represent d over dx equal to lambda. After this, my given equation will become lambda square y minus 8 lambda y plus 16y equal to 0. I have taken out y common out of it. By dividing y on both the sides, after dividing I get the equation lambda square minus 8 lambda plus 16 equal to 0. Here it is my auxiliary equation. You can see that I can now easily factorize it. After factorizing it, I get two roots, lambda equal to 4 and lambda equal to 4. If the roots are real and same, here you can see both the roots are real and same. So my complementary function of a given equation will become yc equal to c1 plus c2 x bracket close e with the power 4x, where c1 and c2 are arbitrary constants. I have a homogeneous differential equation of a higher order. Here you can see the equation is d square y over dx square minus 3dy over dx plus 2y equal to 0. To find out the complementary function of a given equation, I have to put the right hand side equal to 0. I represent d over dx equal to lambda. Now my given equation will become lambda square y minus 3 lambda y plus 2y equal to 0. I have taken a y common out of it. Lambda square minus 3 lambda plus 2 bracket close y equal to 0. After dividing y on both the sides, I get lambda square minus 3 lambda plus 2 equal to 0. Here is my auxiliary equation. You can see that I can now easily factorize this equation. After factorizing it, I get two roots out of it, 1 and 2. If the roots are real and different, here you can see both the roots are real and different. So my complementary function of a given equation will become yc equal to c1 e with the power x, here one root is 1, plus c2e with the power 2x, here my another root is 2, where c1 and c2 are arbitrary constant. Thank you. Today I am going to solve the homogeneous differential equation of a higher order. I have a question d cube y over dx cube minus 2d square y over dx square plus 4dy over dx minus 8y equal to 0. To find out the complementary function of a given equation, I have put the right hand side equal to 0. I represent d over dx equal to lambda. After putting the value of d over dx in the given equation, I get lambda cube y minus 2 lambda square y plus 4 lambda y minus 8y equal to 0. I have taken out y common out of it. Here you can see. By dividing y on both the sides, after dividing I get the equation lambda cube minus 2 lambda square plus 4 lambda minus 8 equal to 0. Here it is my auxiliary equation. If I put lambda equal to 2, you can see that it will become 0. So my first root is lambda equal to 2. By using the root and the systematic division, I get the equation. Here you can see I have done the systematic division out here. I get the equation lambda square plus 4 equal to 0. I get the root lambda square equal to minus 4. After squaring it, I get lambda equal to plus minus 2 iota. It is a complex root. So my final roots are lambda equal to 2 and lambda equal to plus minus 2 iota. If the roots are real and complex, here you can see one root is real and another root is complex. So my complementary function of a given equation will become c1 e with the power 2x, yes, my one root is 2, plus e 0x, here the real part of the complex is 0 and the imaginary part is 2. So it will become e 0x bracket c2 cos 2x, here the imaginary value, plus c3 sin 2x bracket close. We know that e with the power 0 will become 1. So the final answer we get yc equal to c1e with the power 2x plus c2 cos 2x plus c3 sin 2x, where c1, c2 and c3 are the arbitrary constant. Thank you.